Hello everyone. Today we are going to discuss on a topic, Introduction to Robotics. This discussion is meant for the young minds who have been always attracted towards the word robot because of the science fiction movies or maybe because of the demonstration of robots application in our surrounding environments. In today's discussion, we will focus on the preliminary understanding of what is a robot. So, before we start, let us have a brief idea about the history of robotics. If we go to the history of robotics, then it takes us to the way back of 1400. In the sketches made by the Leonardo da Vinci, there were robot-like sketches were present. On the slide, the figure in the middle represents a robot-like sketch made by the Leonardo da Vinci. Inspired by this sketch, a humanoid robot model made up of gears and tendons have been developed in 2002, which can have its own independent motions. Like this, from the different robot-like sketches of Leonardo da Vinci, taking as the blueprints, different robots have been developed which are finding its applications in various domains in today's world. Now the word robot. The term robot first appears in a play Roseum's Universal Robot by a Swiss writer Karl Kapek, written in and around 1921. The word robot originated from the Swiss word called robota, which means forced labor. That means we make a machine to work according to our wish. With these historical backgrounds, if we see the robots in industrial applications, then we find the first robot being used in industry was developed by Engelberger and Devil in 1954. They designed and developed a robot called Unimet, and with this they started a company, Unimation Robotics Company. Later on, the copyright of this Unimation company was owned by the automobile company known as General Motors, and they used for the first time the robots in industrial applications like for decasting or welding or different automation operations. Now, what is a robot? At different time intervals, different societies and institutes have proposed different definitions for a robot, but the most widely used robot's definition was proposed by Robot Institute of America in 1979. It states that a robot is defined as a reprogrammable multifunctional manipulator designed to move material parts, tools, or specialized devices through various programmed motions for performance of a variety of tasks. That is, a robot should be reprogrammable, it should be multifunctional, and it should be sensible to the environment. With these three characteristics, robots have found numbers of applications in today's world. If we see the robots applications, then we find the robots being used in military operations. The figure on the slide shows a robotic gun which can point on the target and fire on the target according to the control from a remote place. Robots are being used in industry for performing mostly the repetitive works and for pick and place operations. Robots in home are being used for entertainment purposes. Robots are being used for exploration of extraterrestrial domains, like the robot rover was sent to Mars, which sends the information from Mars to Earth. Today's date, robots are finding a huge application in the area of healthcare and technology. Robots are being used as surgical robots, where the robotic limbs perform the surgery on the patients and the surgeons remains in a different position, having the control over the surgical limbs. One of the most widely used and advanced surgical robot is the Da Vinci system. And very recently, robots are finding its applications and high commercial demands in the area of sports. On the slide, we can see that a robot is teaching a new learner on how to play table tennis. And on the top right corner, the robot being shown is known as the Sophia, which is the most advanced humanoid robot on today's date. Sophia can understand humans' conversation, humans' emotions, and can react or respond accordingly. Sophia has received the citizenship rights of Saudi Arabia in 2017. So, all these applications where robots are finding their places are governed by three laws as proposed by the Sir Isaac Asimov. These are known as the Asimov's three laws of robotics. These three laws states that the first law states that a robot may not injure a human being or through inaction allow a human being to come to harm. The second law states that a robot must obey the orders given by a human being except where such orders would not conflict with the first law. The third law states that a robot must protect its own existence as long as such protection does not conflict with the first and the second law. Although efforts have been made to follow these three laws of robotics in all the applications, but there are no voluntary or involuntary methods of implementing them, and deviations from three laws are being observed in some of the applications of robots. So, with this we will start with the basic definitions of some of the terminologies being used in robotics. To start with, let us first see what is robotics. Robotics is nothing but the science of robots, and the human working in this area are called robotics. Position and orientation. By position we mean where we are currently being located. But for a robot to understand the position of it, we need to take the help of mathematics, where we define the position by means of the three coordinates along the x, y and z direction. That is, the translational location of an object is known as the position. And by orientation we mean in which direction the object is facing or in which direction the object is oriented. This can be understood by knowing the angles being made by that object with the x, y and z axis. This rotational or angular locations of an object is known as the orientation. The position and orientation, that is the x, y, z translational location and the angles made with the x, y, z, that is the angular or rotational location, is together known as the pose. Then the end-effector, the tools, gripper or the other device mounted at the end of a manipulator for accomplishing a useful task is known as the end-effector. If we consider my hand to be a robotic limb, then my fingers will be the end-effector which I use for performing the pick and place operation or different kind of gripping operations in daily living activities. The link is nothing but a rigid piece of material connecting the two joints in a robot. For example, if I take this robotic hand, then there are number of links present in this hand, which represents the 3 phalanges, as here 3 links are present. And then the joint, the device which allows the relative motion between the 2 links of a robot are known as the joint. For example, if we take these links can rotate about these joints. So, the device which allows the relative motion between the links are known as the joints. There are various types of joints being used in robotics. On slide we can see the revolute joint, prismatic joint, universal joint or spherical joint being used in different applications as per their suitability. End-effector, the volume space in which the robot's end-effector can reach and perform some task are known as the end-effector. If my hand is being fixed over here, then my end-effector or fingers can reach to certain points on a specific volume. That volume where this robot's end-effector can reach and perform certain tasks are known as the work envelope. Now, the degrees of freedom. Degrees of freedom is not a terminology, but also a concept in robotics. Degrees of freedom indicates the number of independent motions along axis or about an axis that a robot can do. For example, a device in the space can translate along the x, y and z axis, and it can also rotate about the x, y and z axis. Thereby, an free object in the space will be having 3 translational degree of freedom and 3 rotational degree of freedom, and in total 6 degrees of freedom. The kinematics is the study of motions without considering the cause of it, that is the force or torque is known as the kinematics, and the study of motion with regards to the force and torques are known as the dynamics. So, these are some of the basic definitions or terminologies being very frequently used in robotics. We will see in depth and more terminologies in our coming sessions. Now, to present, we have the basic units of a robot. So, all the robots usually have 3 components in it. One is the sense, second is the planning, and third is the act or to make changes in the environment. It can be better understood by having its analogy to a human being. Like in our human being, we have different sensory organs like ear, nose, tongue, skin, eye, and from or through these sensory organs we gather the knowledge or the information about our surroundings or about the environments. These informations in human being are being fed to the central nervous system, where these informations are being processed, and from the central nervous system, according to the knowledge gathered from this information, command is being sent to our locomotion system, according to which we perform the certain task. So, very similarly, a robot senses about the information in the environment through some sensors like using the cameras or gas sensors or voice sensors, as well as using the touch sensors. These signals or the information being sensed by the sensors are being sent to a controller in the form of some electrical signals. Then the controller process these signals and gather the knowledge about the environment surrounding the robot, and accordingly it gives electrical signal command to the actuators, which are nothing but the electrical motors or pneumatic actuators, to move with response to the environment. So, like for example, we have here a mobile robot. This is a mobile robot with coupled with the actuators, sensors and the controllers. It has the IR sensors present surrounding it at the different positions, and from these sensors the obstacles are can be sensed, or the different environmental conditions can be sensed, as well, which are being sent to the controller present in inside it, that is ATmega 2560. This information being sensed by the sensors, whether it is the IR sensor or sharp IR sensor or color sensor being present here, being sent to the controller, that is the ATmega 2560 present inside it, which process the information and then accordingly ask or send the command to the actuators, which are in this case are these DC motors. When this DC motors gets actuate according to the command being sent from the controller, this robot takes its movement for performing a particular task. So, at the end we will like to highlight some of the activities being carried out at Tezpur University robotics lab. So, we are working in the field of prosthesis, that is focusing in the upper limb prosthetic hand, and we are working on the mobile robots. On the slide we can see one of the prosthetic hand being developed at Tezpur University, and the middle figure on the slide shows one of the mobile robot which can sense the hazardous gases and can send the information to a remotely located person is being shown. Our students have achieved some of the recognitions because of their activities being carried out in our labs. Some of them, to cite here, Professor S.K. Mukherjee Gold Medal in Innovation 2013, IEEE based Student Project Awards for the year 2012 and 13 consecutively. Thank you.